So I'm very excited. Thank you very much for having us. You're going to hear lots of things during this talk because it certainly wasn't just from me. I work together with a staff of Ifat Peretz-Borenstein, who is an occupational therapist, and kept us all grounded in the clinical parts of what we were looking at. I worked with Shlomit Kayaga-Yampolsky, who is the mother of two autistic children. And in addition to sharing their wonderful sensory experiences with us, she shared her expertise in statistical analyses. And with Dorit Ben Shalom, who's a neuroscientist who is basically the brain behind this whole project. So it's really my privilege to be here to present it, but I'm speaking for many of us. If we talk about sensory processing, we know that over 90% of people with autism will at some point report problems, or their parents, problems with sensory processing. What we know is that a lot of research has been done looking for patterns of sensory processing and different kinds of subtyping of sensory processing in autism. But somehow the heterogeneity of it makes it so difficult, just like Alice said in the first lecture, just makes it so difficult and it's all over the place. So what we decided to do was to do two things that would help us delve a little bit more deeply and a little bit more in a nuanced manner to understand sensory processing in autism. We do want to say thank you very much. You heard today when Elon was speaking about the fact that we have such a rich database. Well, we did this research on the database from ANCOM, and they supported us and allowed us to do it, and we were really happy. The support that we got from them was wonderful. So I'm just going to say this very quickly. We are actually talking about something that is reported quite frequently in particularly by parents, as that is one of the most frequently cited problems that parents report to professionals. Their children are too sensitive, or they're always running and touching things. And because we know that it is so important in the lives of the families of people with autism, as well as the fact that we know that sensory processing really affects functional abilities in everyday life, we know that there is a lot of research in sensory processing, but we also know that it's very complex, very difficult to understand, and we wanted to deal with the fact that it affects communication, behavior, daily functioning, and since it's now part of the DSM criteria for diagnosis, it becomes even more important. There were three basic goals to what we were doing. One is just what I said. We wanted to check the sensory processing and its connection with the moderating factors in autism symptomatology, in daily functioning, and in behavior problems. And that, if you're interested in it, will be published in an article, because that's not what I'm going to talk about now, because you just heard Anat say that she's going to stop me. And I want to make sure that what we can get to is the other two goals that we tried to do in our study. The first one is we really want to know what the role of cognition is in sensory processing. We know that the thought among clinicians and oftentimes among parents is that the more severe the child has autism, the more severe his sensory issues will be. But we don't know that, and we wanted to try and look at that. And the second thing we want to do is to find out if there's anything within the sensory profile which is connected either negatively or positively to adaptive functioning. And that is what we're going to try and do today. We, of course, use Dunn's model of sensory processing. It is registration, sensory seeking, sensory sensitivity, and sensory avoiding. Anyone who wants to learn more of it should not think they're going to learn it here. Just know that we based our use on it. We did that for 3 reasons. One is because there are measures that we can use to measure it, and those measures are in the database. And the second reason is because much of the research that's been done has been done with this, and we wanted to be able to compare our research. But I think most importantly, it's because there's also really good data about this model in the general population, and we really wanted to understand that as well. Again, as I said, there has been much research done on sensory subtyping in autism. We focused on 2 people's models. They both also used Dunn's model, although Astro used a different instrument to measure it. We focused on Astro, who published in 2014 sensory subtypes in children with disorders, and they showed a way that hadn't really been done up till now in looking for sensory subgroups. We followed some of what they did. They continued to study these subgroups, and they're so interesting. They looked at these subgroups as predictors for outcomes. They looked at it specifically in terms of adaptive functioning, and we really learned a great deal about it from that. In addition, they studied with Little about these particular subgroups that we found in autism in the general population. So now we can make those comparisons as well. This is just to show you their beautiful maps. We also have some beautiful maps. The second person that we did was we followed Simpson, who in 2019 also did a cluster analysis to look for subgroups. And they did a wonderful thing because they also tested the measurement itself to see where and how we are combining the specific items to get our subgroups. Our methodology was we took 1,170 participants from the data set. They had to be between age 3, so we took out the children who were younger than that, and they couldn't be older than 15 because that's the age group of our questionnaire. And in addition to that, we had 11 outliers, and we took those out as well. So we basically had 823 participants in our final for our final analyses. We're talking about relatively young kids, but the range was quite wide. What we did in order to look for the sensory profile was we used the sensory profile number 2 for our cluster analysis, and we did have the aberrant behavior checklist, and we had the ADOS, and we had the ABAS, so that basically we could look at all of our measures. This is something that I learned, so I'm going to try to explain it to you so you'll understand how we did what we did. Cluster analysis is an unsupervised machine learning technique that groups individuals based on shared characteristics, but there's no assumptions when you go into predefining those categories. What that allows us to do is to uncover naturally occurring patterns in the data. In our research, we employed a 2-step cluster analysis to identify distinct sensory subgroups based on Dunn's 4 sensory patterns in children with autism. The technique was chosen because of its ability to handle large data sets, accommodate both continuous and categorical variables, and automatically determine the optimal number of clusters. We did it in 2 stages. We first did a pre-clustering to take all of it and make smaller groups to make the second part easier, which was hierarchical. And basically what we're talking about is a sequential clustering approach based on distance measures. What it is, as our wonderful Shlomit explained to me, you take all the data and you throw it up in the air and you wait to see which ones fall together. And basically by looking at which ones are closest, you get your different groups. So the second step of what we did, tried to then see how many clubs we wanted to do and how we could put those together. And what that helped us do was fine our ability to look at groups according to cognition. Why did we decide to do it according to cognition? Well, basically because people believe that people who are more cognitively able have less issues sensorially, though we now know that that is incorrect. But we decided that that would be something that would be very important. In all of the previous research, there are at least two categories that come out. One is a mild category, one is either extreme or mixed group. And what we wanted to do was find out if we could do it. How did we know that cognition was so important? When we didn't take cognition into effect, we got those two groups. That's on the left-hand side. You could see the typical, which is below the line in the middle. You can see the atypical, which is above the line. And you can see the four things from Don's model. When we put in cognition as a continuous variable, which is what most of the research that even takes cognition into account does, we still get. Thank you. I could just have kept talking forever. We still get those same two groups. What you do see, though, if you look on the right-hand side, and I know it's hard to see, so I'm telling you what you're seeing, you will see that we still get those two groups, but we see them a little bit farther apart. In other words, cognition does have some kind of effect. So what we did was we took people with cognitive abilities under 70, less able cognitive, and we took people above 85. And we did that specifically. We also had the group from 70 to 84, and we checked. They were similar to the lower functioning, but we didn't want to put them in there. We take the less cognitively able, 70 and below, the more cognitively able, 85 and above, and then we ran our cluster analysis. And let's see if we get the same clusters or not. And here you go. When we have our 5 groups, starting from the left, we have higher cognitively able people, we have the middle group, and we have a mild group, or almost like average. It means that if you look cognitively, you are getting different groups. On the right-hand side, you have the two groups that we typically see in previous typing according to sensory processing. So what happens is we have a new group, and that group only appears in the more cognitively able people, and that group deserves to be studied to see what we can do with it, can understand from it. And what we understand from it is quite interesting. We see that that is the only group with a statistically significant difference in avoidance as opposed to the other 3 areas. So we looked at the items that were avoidance items, and those items are holds ears, hands over ears to protect them from sound. Definitely sensory. But is bothered by bright lights, hides from sunlight, also sensory. But there's others. Shows an emotional or aggressive response to being touched, can be stubborn and uncooperative. And when we see from this is that some of the avoidance items are also behavioral or emotional. I'm going to try to summarize this for you and basically say that sensory processing patterns vary with cognitive ability. And when you read any paper that you are reading, if they haven't taken cognitive abilities into account, then there might be something that's missing, that's getting swallowed up by the rest of the rest of the data. And I think it's really important for us to be aware of that. We found that even when you take cognitive ability as a continuous variable, you cannot necessarily identify the subtypes. So we would like to recommend that not only should cognition be taken into account when looking at sensory abilities, but also that it's done categorically so that we can talk about those with more cognitive ability and those with less cognitive ability. That immediate group inside the sensory profile of more cognitively able children was associated with better outcomes, specifically better adaptive daily functioning. That must mean that avoidance as some kind of mechanism for helping people function better in the world. Now, that's something that's new to our results, and we feel that we need to get the word out there so that people can do it. Because once we understand these groups, we can also tailor the interventions in a much more individually appropriate manner. Again, this is one research. We're going to have to explore other um, um, methods of subtyping and see if it comes out there too. And also understanding that this can help adaptive functioning, maybe we should look at this as compensatory. Maybe we can perhaps learn about it and explore strategies that support adaptive functioning in the less cognitively able people that we can learn from what we see in the more cognitively able people. I think we need to make this also with older children or young adults or adults, but maybe the most important message is that it is possible that avoidance is not necessarily something problematic, but it also is something that we can do. Here's your take-home message, because my time's up, okay? We have to deal with cognitive abilities. That intermediate group can teach us something. Avoidance might be something to do with self-regulation that we really want to get into. And we can deal with developing strategies for both parents and teachers that might help manage that sensory stimuli. Because actually shielding people from extensive and excessive sensory stimulation might bring about better adaptive functioning. What I want to say as my final thing is that sensory issues are still not well understood, despite all the really good research that we have. But if we can understand sensory processing and sensory issues in the broader context, then maybe we can understand it and help people understand, manage, and actually use some of their sensory abilities as compensatory problems. This is really, really a very small step, but really important step in understanding sensory functioning. Thank you.